This lesson is about graphing exponential function f of x equal to ab to power cx plus d. Um, remember the parent functions. If the function is g of x equal to c to power x when c is bigger than 1, it's an exponential growth, and there's an asymptote as x goes to the negative infinity. Now, this becomes an exponential decay if the parent function is b to power x. And how do they compare? We can compare this with, we can rewrite this as 1 over b to power negative x, and that means that then 1 over b is going to be bigger than 1, and it becomes a function base to power negative x when base is bigger than 1. And so that explains why these two are a mirror image of each other, or reflection of each other over y-axis, because of course, and C and B have to be reciprocal of each other to be, they can be the mirror image of each other. And then the y-intercepts is 1 for these two. Now, with that, just remembering that, so when I'm looking at this function, I'm expecting that because it's 2 to power x. When I'm looking at this function, I'm expecting approximately this one, because this one is the one that this one is the decay one, because 2 to power negative x means 1/2 to power x. Then comparing them, in the best way to do this is to remember what is important to us is either we get this shape, or we get the reflection of them over the x-axis. And this one doesn't have any reflection over x-axis. That one has a reflection over x-axis. So the approximate shape of this one follows that without any without any reflection over x-axis. Approximate shape of this one follows that with a reflection over x-axis. So I'm expecting it to be like that. So approximate shape is important. We call it concavity over here and over there. Then the discussion is, the other part of the discussion is the behavior as x approaches infinities. This one is going to follow this behavior, except that the horizontal asymptote y equal to 0 is going to be moved up 5 steps, 5 units. This one is going to follow that, but horizontal as x approaches infinities, except that horizontal asymptote is going to be moved up 7 units. So now that I know, I put the concavity approximately there, I put the concavity approximately there, and then I draw at y equal to 5, because the asymptote moved up 5 units. I want to put this shape in. I need a few points. I suggest putting in x equal to 0 and finding at least 1 point. Putting x equal to 0 will give me 3 plus 5, which is 8. And so let's move this down a little bit. Let's say this is 5 and this is 8, and this is the horizontal asymptote. And so I'm expecting this to go down, and then I'm expecting this to go up like that. And then always a few more points to make the shape a little bit more accurate. Does that 3 matter? When you plug in points, you will see the difference in that 3. I would not suggest just by moving any of these shapes. It's easier to just find a few points and put it on the graph. I'm actually skipping that part, but let's move on to this one. And here how it is. Add 7, add y equal to, so this one was 5 and was 8, and this one is 7, and then plugging in 0 gives me 5, so it goes through this point, and I know that looks like that concavity, so it goes down and it goes like this. The next step is to find, if you can see that there is an x-intercept, to solve an equation to find that x-intercept. But how do we solve that equation to do the x-intercept is a question for the exponential the equation with exponentials, and so we take a rain check on finding that point, but we put a few points over here. For example, you can figure out what at x equal to 1 what value is here, and add a few points here, what are these values, and then graph it beautifully. But to find this point, you have to wait until a little later when we discuss the exponential equations, and then we come back and finish this one off.